Hello everyone, Akshay this side. Okay, I can see 7 attendees. Hello Altrash. Hi Ashish. Hello Deepak. Hello Neelgandan. Hello CV sir. Hello Shweta. Hello Vishaka. So one by one, I will be sending the request to be in panelists. Kindly accept.
Hello, good evening, Ashok.
Hello sir.
Sorry, I couldn't make it last Saturday, Sunday. I was on business
Yeah,
travel,
yeah.
so
Okay.
I couldn't join. So I'll watch the recordings.
Yep. I introduced a new topic that was decision tree. Okay,
I
so
was going through the I was going through the Iris machine language
okay, great, great, great.
book,
So
so
that
I'll go
was
through the
like
recording.
multi class label logistic regression. Not logistic, it was a decision tree, but it was a multiple class level classification model. Mhm. Okay, I'll Atarsh kindly accept the request. Neil Gandan, please accept the request. Priya, please accept the request. Shweta again and Viramani. How are you, Viramani?
Yeah, good evening, sir. Fine.
We'll wait for another 2-3 minutes there and then we will start. Please let me know if you have any concerns regarding the previous topics we discussed. I'm sending you the request to be in panelist. Same with Divya. Same with Neil Gandan. Same with Sri Devi. Yep. So we will start now. Okay. Divya, yeah, we just started. Yeah, I was waiting for somebody else. If is there anybody? I think we are done. I think we have the good strength today. Yeah. So we will start today. What we will cover. Okay, I will just share today's agenda. So for those who were attending it last week, what we did is to understand a decision tree modeling approach. Okay. So in decision tree, we will cover this. We will complete it. Okay. What I left at that day was this one, this slide. We will understand what is this technical terms called Gini and entropy calculations and how we can use them. Okay. After that, I will also cover what I left few classes back. That was one hot encoding. Okay. So I will not build a full model or something, but I will tell you how to do that dummy variable creation for that logistic regression modeling or for any kind of modeling where your categorical data is present in the independent variables. Okay. So we know that for dependent variable, we can convert it already into the binary or any kind of a coding like label encoding. But for variables which are of categorical type and are present in independent variable list, okay, what to do for them. Okay. And post that, if we are having time, then we will understand a new algorithm which is called k nearest neighbor, and I will go with the analogy. Okay, grain and cup size, that's a kind of an interesting one, and you will be able to correlate from your real life how this algorithm was into your childhood games also. Okay, but we never knew. Okay. And we will understand how this algorithm works in its maths. Okay. And what are the Euclidean distance in this particular algorithm. Most probably we will be covering a decision tree. I don't think so we will have that much of time, but tomorrow we will cover all this thing. We will have a supervised machine learning algorithm for classifications also. Let me just open the uh, course curriculum so that everything is in our agenda. Let's just yep. So Dealing with categorical independent variable, just like I mentioned, this will be our agenda, one hot encoding versus dummy variable, what we will cover. And what we are doing right now, we are covering the concept of decision tree that we have known. Today we will understand what is the usage of Gini and entropy. What is information gain also, maybe not in this class, but in a random forest, I will explain you in more detail. Visualizing the decision tree nodes and splits that we are doing already. Okay, that we did yes in the previous week class. Working, that is the all working we are doing. And we know that decision tree models belong to classification problems. Okay, so in classification problem, you go with that your confusion matrix. Okay, and in confusion matrix you get the measures like accuracy, precision, recall. Okay, and you can have your doubts. Okay, after that we will understand another classification which comes under the supervised learning, obviously, because we will have a dependent and independent variable like situation. We will understand extending the decision to regression problem. I will explain you in a concept. Okay, after that there will be a Bayes theorem which is also used in your decision, or sorry, in your classification problem. Gaussian naive Bayes classifier and KNN classifier, as I mentioned, because it is the easiest to understand. Okay, so we will cover this. And most probably in your week of mid of December, maybe somewhere around 17 to 18, 10 to 11, we will have this support vector machine. And then unsupervised learning algorithms will be starting somewhere around like 12 and 13. Not in December, obviously. In December, they will be starting at 10 and 11. And by the way, I also wanted to let you know, guys, that for third and fourth, I won't be available. I am having my some personal errands as well as some official meetings that's outside uh, my like area that I'm living. So I will be traveling a lot. So in that, it won't be possible for me to get to a stable connection. I can deliver those things, lectures, but like because I'm traveling, so it won't be visible for me to get a stable connection, and it will eventually create a bad experience for you guys. So let me know if it's fine. For third and fourth, I'm doing a prior announcement for that next week. Okay, so that's why we will be having a little delay on like approaching the unsupervised algorithms. So that's why we will cover them from uh, 17th or maybe 11th. Okay, and that's PCA is also under the same unsupervised uh, learning and ensemble modeling that we will cover in supervised learning. So that's all, like kind of a near future agenda. Let's focus on today's problem statement. That is our decision tree and explanation of entropy and Gini. Let me just do a little revision for those guys who were not present. Okay. Okay, what uh, we did is that yeah, what we did is that a simple problem statement of height and weight. Okay, we have a data of different people, of their heights and their weight. For example, this x-axis is height and y-axis is weight. Okay, and you see these this is a scatter plot. So for example, for a person 5 feet, and weight of 60. So it will be plotted somewhere here. And with the help of colors, I have mentioned that for males, the color will be blue, and for females, it will be like a dark pink. Okay. And this is kind of a scatter plot. Okay. And you will observe that there are two straight lines, which is in yellow and which is in blue. Okay. And in order to make a rule, can I make a rule by looking at the scatter plot? Okay. Can I make a rule that, hey, and it's rule for somebody who doesn't understand this data, who haven't seen the data. And by understanding the data, that person should be able to make a rule that if you find that people less than 5 feet 5 inches and less of weight, then there will be X much of females and there will be X much of males. Or if I give that person weight and height, then that particular rule should be able to tell me whether that person will be male or female, because the rule is made after studying the data patterns. Okay. Now, what are rules? What are rules in your general life? Rules are like uh, or conditions. I should say that rules or condition, just like terms and condition. Okay. So terms and condition says, if you found to be doing this, okay, if you found to be litter on this road, then you will be charged with that much amount. Is it like the terms and condition? If you return this item on Monday, okay, then it will be returned. If else, if you take more than 5 days of time, then the item will be not returned. Is it like the terms and condition? Can you agree, guys? When you purchase an item from a mall, there on the slip on that particular receipt, they light like on the bottom small, the terms and condition. If you return this item after 5 days from the purchase, then it will not be returned or exchanged. Okay, like terms and condition. So can we make terms and condition by understanding this data, just like in that if and else and then clause? Okay, guys, I will have to attend a important call. Just give me 2 minutes. Thank you, guys. Okay, so can the bottom line is that, can we make some if and else rule or terms and condition, so that if we apply these terms and condition to unseen data, we will be able to know what will be that then. Okay, so in this data, I am saying that I'm aiming to make a model. Okay, ultimately it all boils down to the problem of classification. Can I make a model from this pattern or the scatter plot such a way that I will make a rule, and that rule, following that rule, will make me at the end whether that person will be male or female. Okay, so that's the bottom line. So in order to make such rules, okay, I will have to use that if and else clause. Okay, now the starting point is that in the scatter plot, if I draw a line at 5.5 feet, okay, in straight, then there will be left and right. Okay, in left, what is the proportion of female and male, and in the right, what is the proportion of male and female? So you can see that written over here. Okay, now in any kind of classification problem where you are doing the work with the help of a model, you will have to give model a event. Okay. For you, let's say your event is that you wanted to predict the males. Okay. If you predict the males, then in a binary case, automatically the female can be uh, predicted, because there are two cases. So total minus the males will be like your females. Okay. So our event is our, let's say, this male. Okay. Now with this particular event code, which you will say that it's a positive for you, you will check the proportion of this particular male or female. Okay. Whether your male or female, whatever you have chosen as an event, is is reaching to a point where you can clearly distinguish that if I follow this rule, then I will be able to find x number of male or female. Okay. For example, in this, if I choose that people less than 5.5 feet, then there will be 9 females and 3 males. Okay. And if I choose that's criteria of people more than 5.5 feet, then there will be 6 females and 10 males. And this is all we counted in the previous class with the help of you guys only. Okay. And on the left itself, okay, if you make another rule of from these people which are there in this left side, if I make another cut or split at 4 feet, you can see here, then I will be able to get a proportion with less than 4 feet of height, with 1 female and 3 males. And if I choose less greater than 4 feet, then I will have 8 females and 0 males. Now you won't further split this node because this has reached to a pure state. What is pure state? Either one of them, either one of the event code, event your like classification values has reached to a point where it can be classified directly. Now, doesn't it I make a rule? The rule says that if height is less than 5.5 and if height less than, sorry, greater than 4 feet, then you will get 8 females. This rule is worth yes. Okay. So out of total, if I make a rule that if you go with the person's of height less than 5.5, and within them, if you find those people greater than 4 feet, then you will get 8 females. Okay. If I more compress this rule, I will say that in order to get 8 females, okay, if you wanted to know if your rule, if somebody says that there is a new lady in this particular data set who is having 4.2 feet of height. Now, can you tell me this particular, sorry, I should not say female. So there is a new person of 4.3 feet. Now I'm saying that take this data into your model and tell me what will be the gender. Now in this model, you know that people more than 4 feet and less than 5.5 feet, if this is the criteria, then there will be always females, which are 8. So you can see that of people 4.3, you will surely get a female. Okay. So this rule was used to filter the new data, and rule should be that it also works perfectly fine when new data is there. Okay. Because you have made this rule with some set of training examples, and your model should even work if it has seen some data which was not in the training. It can predict still, but if the data is still not was not the part of the training program. Okay. Yep. Yeah, you're correct. You're correct. So if I say that I have lady of 4 I would say that if there is a new addition of 5.6 feet, what will be the gender? You can see that according to this rule, if I just follow that rule, which was on the left side, it will indicate that it is a male. Okay. But which is, yeah, can female and or male. Yes. But in order to be precise, do you need still more criteria to filter out? Like, obviously, if height is more than 5.5 and weight is also at some criteria, then that particular person will be male or female. So it means that you still need more rules, a complex rule. Okay. It could be like uh, set of 12 rules, set of 13 rules. The point is that rules have to be made. And how you make a rule? Okay. You make rule on the with the help of the variables itself. Now in this particular business problem, we have two variables, height and weight. Okay. But in real problems, you will have 12 variables, 30 variables. Okay. So in order to process that, you won't be using that scatter plot. Scatter plot is all only fit for two variables, which you can plot on 2 dimensions. But what about you have 36 variables? Then in that case, some of you can say mathematics comes into your play, like Gini and entropy methods are used. Okay, Gini and entropy method are still used in two variables also, but I will explain. Okay, now the point is that why you splitted this one, that 9 and 3 on the left side itself with the help of this blue line. Okay, the blue line was pointing towards 4 feet. And once you create a split, there are always two parts, left or right. Okay, or it could be like top and bottom. Okay, whenever you split, you are creating two branches, isn't it? Okay, now in that two branches, there will be still proportion. Now how you decide that I should split this one or that one? Okay, now the point is with the help of a calculation called purity. Now I explained you with an example. For example, you have 10 kgs of sugar and 1 kg of salt. Okay, and you mix and match, you prepare 2 boxes with box 1 having 9 kg sugar and 2 kg salt. They all are mixed in one box. Okay, and there is another box with 9 kg of sugar and 0.1 kg of salt. Now which one is impure or more impure? Again, yes, Shweta. What about CV sir? Are you do you agree with Shweta's answer? Box 1 is more impure. Thank you, Ashish, for acknowledgement. Impure. So Altrash, pure. Pure, opposite of pure is impure. So what is pure? Box 2, because it is having majority of 9 kg of sugar and there is only a pinch of salt. So even if you, yeah, yes, box 1 is more impure because it having 2 kgs of salt. Even if you wanted to make something sweet, it will be not there because there will be some salt into it. Okay, but with the box 2, even if you have 0.1 of salt, it will ultimately taste better than the box 1. Yes, so my question was, Alatrash, which one is more impure? So opposite of that. Okay, so you just have to do that negation of whatever you say. So in that case, your statement is correct. Box is, yeah. Okay, fine. Now in this problem also, look at each node and look at the proportion of female and male and ask the same question. Which of the node is more impure? Okay, now look at this node. Uh, can you guys see my mouse or cursor? Yeah, right is impure. Yes. Yeah. So in this particular box, which one is more impure, right or left? Yeah, correct. Correct. Okay. Yes. Okay. So the point is impurity. On the basis of impurity, you decide whether to split or not split. Now, if you split the right, what do you think will be the criteria? Don't look at the left L part. Okay. Even from this yellow line, don't look at the left part. Look at the only right part. Do you guys think, is there any criteria on weight where you can see that you can make a line and it will help you to reduce impurity? Do you think, is there any split I can make? That will become a rule also. Okay, let's see. This is at 6.2. Yes, Altrash, correct. But that is again on the height. Okay, that is fine. I think it's makes sense also. 6.2. Yes, because it will make a more divide. It will make a big divide. Let me just do it also. We can make a split at, somebody is suggesting 45.6, 45 to 60. Okay. It will be 6. Okay, it will be 6 female and 1 male at okay. Yes, Altrash, I got it. Yeah, I think that's makes sense. Let's make a color so that we can differentiate that one also. Let's take red. Okay, let's make a split at what Altrash has mentioned. Okay, at 6.2. So let's just make with the same red. Okay, so red color signifies for the third split. So let me just draw it also. Split 1, split 2, split 3. Make sense? Come back to the color red. Guys, please tell me the proportions at the third split. Okay, now at this. Okay, we have how many females? 1, 2, 3, 4, 5. 5 females at the left. So I will choose that color. 5 and 1 male. Oh, sorry, that will be with the blue color. Okay, and at the right of this new split, how many will be there? 1, 2. 2 females and 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, okay. Yep. Thank you. Thank you. Yeah. Now, tell me, looking at this, the third split, and third split has given a left and a right. Which is more impure? Left is more impure. Deepak said right is more impure. Okay. 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 Right is okay. Okay. I'm not going to do the calculations. I'm just believing your opinion, guys. So I think I'm going with the majority. Okay. Because you know that this data is something that I haven't planned. I just fit randomly and I'm doing it. Okay. I try not to program everything. Okay. Yeah. Ratio. Left is 20% and right is 22%. Yep. Kind of something. Yes. But CV sir and Deepak, I will give you a formula. Why not to use this formula? Okay. This formula. Let's understand this one. Okay. Now look at this particular node, which is exactly what we are doing. Okay. There is a something A, let's say, and we have divided into a, let's say it was something like yes and no rather than a height. It was like whether the person is smoker or not. Let's say if that is a smoker, then there are some proportion. And if that person is no, then there is something which we are measuring. Now what we are measuring, okay, let me just remove it. Okay. So I told you in the beginning of the decision tree, purity, if you understand this purity or impurity, let's say impurity, because we are focusing on impurity. If impurity is zero, if impurity is zero, then what does that mean? If impurity is zero, that it means it is 100% pure. Yes, 100% pure. Okay. Yes. So it means that this node 1 has reached to a level which is like stable state. And if impurity is 48%, then it means that there is a further scope to split. Okay. Now, in this particular case, whatever the variable was, let's say smoking, whether that person was smoking or not. For yes, the class variable 1, the class variable value number 1, for example, let's say it's a gender. Okay. Let's say there is a variable gender. Instead of male and female, say this is C1 and C2. Now, in this node 1, there are 3 males, and in this in the same node there is 0 females. Same goes with the for node 2. So here it is like 3:0, 4:3. Now there is a perfect way to do the calculation, just like in our case. What we will do that, like we will do a 1. Okay, that is like 100 minus what is the total number of class, like majority. Like if we just add up these things, 3 plus 0, it will be 3, and here it will be like 7. Okay. So out of total, okay, for the one class C1, it will be like 3 divided by 3 and to the square, minus 0, which is that class 2, divided by 3 square. Whatever the number will be your Gini coefficient. Same with the N2. Okay. Yeah, it is already there, sir. Viramani and Ashi, I think Viramani. So if you go to the drive link, so this was already shared with you when you was learning the linear regression. Okay, let me just rephrase this formula so that you guys can understand. 1 minus C1 divided by N, which is the total, minus C2 divided by N to the whole square. This is done at every node. Okay. So this was for that N1 node and this is for the same. So you will see the calculation. Now you will get that. And you can also calculate that total Gini coefficient. Okay. Okay. I will tell what is that thing. Now look at the formulas. IG, that stands for Gini index. This formula, let's understand from that statistical notations. 1 minus this J stands for how many values are there in a categorical variable that you are studying. For example, in iris, how many types of flowers were there? 3, correct. So what could be like in that case? What will be the value of J? 1, 2, 3. 1, 2, 3. Now what if I expand that? So it will be like 1 minus C1 divided by N to the whole square, C2 divided by N to the whole square, minus C3 divided by N the whole square. If I correct this, then it will be like 3, 3, 3. Okay, whatever the value will be, it will be your Gini index. Now, if you take log in between, then it will become entropy. It's the same formula, but if you take log at every calculation, then it becomes entropy. Okay, why log? Because log is like simplify the values and the scale. As I told you already, log is just like making your life easier by simplifying the calculations. Guys, just a minute, I have to take a call. Yeah. So come back to our problem. Any doubt till now? Any doubt till now in this formula? Thank you. Now with this thing, we can do the same thing. We can calculate always base 2. Yes, correct. Correct. So in this case, what can we do is that 1 5 divided by 6 to the whole square minus 1 divided by 6 to the whole square. That will be for the left one. And for the right one, it will be like 1 minus 2 by 11 the whole square minus 9 divided by 11 the whole square. That will be that in Gini value. That Gini value will be compared for the further split. Okay. If impurity reduction at every node is achieved, okay, reduction should be there. The impurity should reduce. Now, what is the mean of impurity reduction? It means you are going towards nodes like this one. Okay. Now just try to calculate impurity of this node. 1 8 divided by 8, 0 divided by 8 square. 1 minus 1 minus against what will be that 0 or yeah. So it will be like 0. Okay, so impurity of this node is 0. So impurity has reduced to 0. So that was the ultimate criteria. So in any algorithm, I told you convergence. If you remember a term that I told you, convergence, till when? The question is like till when. Now the till when is something answered by the convergence, and here the convergence criteria is reduction of impurity. Okay, as long as you are reducing it, but it should not be like that you are making rules to a such level that it is like 1 and 0, 0 and 0. No, it should not make a rule which will be like going to each and every data point and remembering that what is that criteria. No, your rules should be generalized so that when a new data comes, you will filter that new data with the new rules. Now look at this particular example. What we have done so far is that if height, look at this rule. If the height is greater than 5.5 and if height is less than 6.2, then five females and one male, comma, two females, nine male. Is it like reaching to a stable state? No. It further needs a split so that we reach to a leaf. Okay, we reach to a leaf. Now I explained you that understand this as a reverse tree. Okay, where everything is starting from there, splitting into branches, and that branches still splitting into sub branches and so on. What is the end in a tree? A leaf. Okay, at the end of it there will be a leaf. Let me just try to draw a leaf. Okay, at the end there will be some leaf. What is that leaf in decision tree? Leaf is that one stable point, like you will find one male and zero female, something like that. Okay, so it should reach to a leaf something like this leaves. Okay, 8:0. Okay, it should not be like 1 0 1 0. Okay, or it should be like 2 comma 0 or 0 comma 3, something like that. But it should not be, you should try to avoid that 1 0 1 0. Otherwise you will be able to you are just memorizing the data with the help of the rules. Okay, it should not, it will just miserably fail when you will give the new data set. Okay, okay, now can we calculate the impurity? Someone do that impurity calculation. Yeah, yes, Viramani. Splitting further and further, then sample size may small. Yes, correct. So that's the problem of overfit. So you are not going to make splits in such a way that it will be like you are reaching to leaf node. Okay, try to make the rules as much as general. And one of the major rules, one of the major ways to make these rules as general is to like stop at some point. Don't get under the skin of the data. Okay, don't make splits, something like that. Hide this one. Okay, at this one also make a split. Okay, how many splits you will make? You will have no limits to that. In that way you will be able to reaching to a one granular data. You will make so much rules, and also too much rules are not good. Okay, because Once you have the new data, then it will be hard for the rule book to qualify and filter because it will do some wrong. Okay. Now each of the split S1, S2, S3, okay, they are called decision nodes. They are called the decision box or something like that. This is like a node. And at every node, entropy or Gini is calculated. And with the help of that value, you will see that where the value is approaching towards 0, okay, you will split those values which are not moving towards 0. Okay, impurity is measured in the terms of Gini, and opposite of impurity is purity. Now, can we have a split here in this particular, or maybe we can do that split by this right node first of all, okay, because a lot of people said that it is more impure. So can we make a split on the basis of what? We should use a weight also for splitting. Can weight be identified as? I think let's just try to do this one. If I make a criteria at here, no, I think weight is not giving us much. You can say pure nodes. Okay, so sometimes these variables are also chosen on the basis of impurity. It's like not sometimes, always. Our dependent variable is the gender. Okay, that's why you are checking that dependent variable whether it's you are able to predict or not. Yep. Yes, Ashish. Yes, you're correct. So don't try to make such rules just for doing it. Okay. Maybe the another data that you will have will not have that much of a scatter plot pattern. It will have something different. So your rule should be generalized. Okay. You understand all this, how this calculation is going on now. Right time to do something. Okay. We will have a way. I will have a break for 5-7 minutes. Okay, how 2-9 is optimum? No, it's not optimum, Shweta. It's impure. It's more impure. Do the Gini calculations. Yeah, do the Gini calculation. Let me just do it for understanding it. Let me just go to that one. 2 divided by 11.8. Nine divided by 11. Okay, and here 0.81 multiplied by 61. 1 minus 0.0324 minus 0.6561. Okay, so here the Gini value is 31% impure. Okay, and about this 5 divided by 6. So 69. 1 divided by 6. So you can see that the right node is more impure with 31% impurity, and left node is, yep. So who will be split it first? 2:9. Okay. And then that 28.3 will be split it. Yeah. And also what this algorithm does is also checks if I split on height, what will be that point and what will be the impurity back then. And it also checks if I split on weight, then what will be the impurity. Wherever it finds that impurity reduction is more, mark my word, impurity reduction is more, okay, then it will go towards there. Okay, wheresoever stable state is in looking a good state, like where it will be achieved, it will go there. Okay, so it can be used like we can do it although something like at this point we can make uh let's try to make a orange line. Okay, you can see that if I split it, not this like on the right, if I split and make that criteria something like, let's take the orange one. If weight is less than 55, is the weight is the criteria and 55 is the cut point, less than and greater than. Okay, what will be that proportion? It we will check the proportion. Okay, so on the top side, which is like greater than 55 kgs, so it is like it will be like 5 and 1 female, 1, and on the bottom it's like 1 2 3 4 and 1. Okay, yep, Ashish, correct. Okay, so this way again the impurity will be calculated for, or Gini index will be calculated for this one and this one, and it will be a into a, it will, if there is a rule which can split, I think there will be individual rules, but it will further not add any value, I think so. For example, if you make another rule here, let's say for, let's choose a different color. Let me just have that green color and make a split at this point time. On the right itself, like obviously on the weight greater than 55. Okay, so this will be further splitted into, the color is green. Okay, weight is at 75 kgs. If at 75, so less than 75 and greater than 75, what is the proportion? Let's check. Females, when weight is less than 75, there is 1 female and 2 male. 1 and oh, I did it reverse. Yeah, fine, correct. And here there is like 2 males only and 0. Now in this particular, this node has achieved a stable state, 100% pure. And about this one is still 50%. Okay. Now this one will be further not split. Okay. If you go by down that, like try to see the rules, how the, please interchange the value in the right side. Okay. Okay. Let me just check. Two males and 0. This one. Okay. So this has reached a stable state. Okay. And that is only the story from here. I know this is like quite messy, but is it making sense to you all guys? Yep. What about CV sir? Are you sir understanding? You skip the class also.
I think I'm following so far in terms of actually we are splitting how, and the splitting is
Yep.
basically wherever impurity is more, we are just splitting into equal proportions, right? Like,
Like
for
splitting
example,
is like the more like an English word, but technically it's like selecting a criteria and seeing the left and the right or the top and bottom.
correct. And that criteria that you're picking up is basically how do you pick that specific criteria, which I'm not
Yeah.
clear because I
Yeah.
didn't.
So it checks. What it does in algorithms, what it does is that just like you guys are doing it randomly on your visual, you can say analysis, what actually machine does is that it checks, it tries to do some checks, like it checks like for the first split, let's take the first split, the yellow one, we chosen the height of 5.5 feet. So what it will do, it will check from let's say 3 or 4 feet, it will check what is the proportion. Okay. And also proportion are check in the form of Gini. So at a point where it will find that impurity reduction is happening, it will make that criteria. But here why I have chosen a visual criteria, because you can understand how, because even what you are seeing visually is also to make a pure state, like a pure split, isn't it? You like, I don't know who given this me answer in the previous class, that Akshat chose this 5.5 height. So sir, can you just repeat why you given me that 5.5? Because looking at it visually, you are seeing that on the left side you will find the majority of females and majority of or minority of males, something like that. So the criteria is looking at the pure or impure split. So you either go, you wanted to go with a pure split or impure split, you check any of them, you will reach to a conclusion that I will have to split at a value where one of your goals will be matched, like it will be like satisfied. Okay. Steve sir, any doubts?
Yeah, fine. I think if I get more background, watching the recording, it should be okay. I'll
Yeah.
watch.
Okay. Okay.
I'm fine so far now.
Great. Okay, guys. So that was the splitting criteria. Let's have a break and then we will jump to Python and see how Python does this beautifully with the help of a visual, and how we can set all these criteria like entropy, Gini, and anything criteria like that. Okay. So we will be back again. A break. So guys, I think one person is facing some issue, I guess. Only Neil Gandan is there in the attendees.
No, you're all here.
Okay. Okay, guys. So let's, we have learned so far the rules. Okay. Let's just. Yeah. Give me a moment, guys. I am pulling up new notebook. Yeah. We can now go ahead. Same problem that we did. The iris. Okay. We did also with the help of logistic regression. Now we will fit a decision tree. Okay. The problem statement is same. We have to predict whether the class of the new flower, the data we will enter will be of three types, whether it will be setosa, versicolor, or virginica. So three labels for the target. Okay. And it is already encoded into binary format. So 0 stands for setosa, versicolor stands for 1, and virginica stands for the 2. Okay. So it is already into the format. Only the independent variable has to be taken care. Okay. So we will load the data set and we will see the independent variable list. And on the basis of these variable, my model should be able to predict whether the flower belongs to either of the category, either of the three categories. The target is target. We have already got it from the sklearn. Target names are like this. Okay, we will do the train test split, and we have divide like 20% is selected for the test out of the total. Now we will fit a classification, that is the decision tree. Okay, so there is a library to visualize. Okay, and also to make a decision tree, you will have to use like from sklearn import what module? Tree. And in tree, you will see that once you use that tree, there are all sort of tree based classifiers or regressors. Now, what is the regressor? Any model or any this is the algorithm. So this algorithm, the regressor algorithm, will predict the values, and classifier will predict the categories. So the dependent variable for regressor will be a numeric variable, and dependent variable for a classifier will be a multi-label variable, just like in our case. There are various types of tree-based model: extra tree classifier, extra tree regressor. Okay, and there is also option called plot tree. You will be able to see that splitting and everything. Okay, so we have done so far. Let's run. And what we are saying that from the tree module, give me that decision tree classifier, and I'm making a random state of anything. Okay, let's say 44, or let's say anything. This particular CLF is our object of the decision tree classifier. And in this object, we will pass on. Let's see what are the objects, what are the functions available in this object. CLF. CLF is a classifier. Any questions? Deep, who is Viramani? Yeah. Do you have any question? You unmuted yourself. Okay. So in this CLF object, which is the classifier object, you will say that a lot of things, CCP alpha, CCP weight, lot of complex thing. I will explain one by one. Okay. Yeah. Okay. We will provide the model, the inputs. So the X trained, which is like the training data for independent variable, and the training data for the dependent variable. We will fit it. Okay. So model is there. Just like everyone, I already given what is the meaning of the CLF underscore n outputs underscore and n classes. Okay. Let's do with the split. Happen. Okay, I have to run it again. Yep. So score is testing score is 93%. Okay. And here is the confusion matrix, and confusion matrix is something that we all understand, and there is a classification report that we can see that for the precision and recall. Now, the important thing is that looking at the tree structure that it has made and the rules that we all talked about. Okay. Now, let me just what I'm doing right now here is that I am predicting, I am putting that predictions as well as the original values of that particular it class it belongs. So you can see that this flower at index number 1 was predicted to be of class 0, whether it was 0 itself. So it's a correct prediction. It means true. And here in this third index, the original value was 2. It means it was a, I think, Virginica, but the model predicted it to be of, but I think the 1 category. So it's a misclassification. So you can see that all classification and misclassifications. Okay. Let's try to plot it. Okay. So in order to plot, there is the same thing like plot tree function that I have to use. And in the plot tree, what I have to do is that plot tree, and you will have to pass on the parameters. What are the, what is a decision tree? CLF. Okay. Classification model that you made. So the model is there. Okay. The rules are in that CLF object. And what you are saying that max depth, what should be that plotting, because it's a huge data. So it has made so many rules, and but do you want all the rules to be made like printed in this graph or not? For example, I might choose that, hey Python, give me diagram till this stage. Okay. Or I can say that Python, provide me all the diagram till here, like this one. Okay, so you will see that the depth concept. What is a depth concept? This is like level 1. Let me just do it here. This is like level 1. Here there is a level 2, there is a level 3, and there is level 4. Now this level is known as the max depth. So you are saying to Python that plot the graphs till the max depth of 5 and put the labels, all labels. Font size should be 7 and it should be filled graph, like color should be used there. Okay, so it has plotted in a smaller, so I'm going to increase the size with the help of PLT figure fig size, and you will be able to see a full grown tree with the rules. Okay, now just understand from this. Is it same thing resembling for what I did? Okay, now see that in this graph, let me just cut it here. And take this graph here. Let's try to analyze this one. First of all, look at this and our graph here. You will see a kind of a structure which is like splitting. Is that true? Yeah, you will be able to see that splitting is there. And at some point, the split is not happening like this one. And here also splitting is not happening. You can see the orange one. Now the color stands for the 3 kinds of colors of flowers, like 3 kinds of flowers, like Setosa, Virginica, and the other one. Okay, Setosa, versicolor, and Virginica. So for Setosa, the color is orange, and for Virginica, it is the purple one, and for versicolor, it's the green. What does it mean? I think it has taken the color combinations. Yes. Now you should see that this graph carefully. Now the criteria, just like in our case, we did it with the 5 feet 5 inches. Now the petal length is selected with less than 2.6. Gini at that point time was 66.7%. 66.7. And the total number of samples were 120. And how this 66.7 was there, let me just do the calculation. You can also do the math from your side so that you will be able to understand it more. 39 divided by for this one, 1 minus 39 divided by 120 to the whole square. I'm putting up the Gini formula. 20 for the first node. Okay, 40 divided by 120 to the whole square. 39 divided by 120. Sorry. Yep. So 1 minus yep. So if you do the calculation, it will be like coming out to be yep, correct. Now this initially when you didn't split, your impurity is 66%, 66.7. Okay. If I round it up, it will be like 67. Can I do that? Yes. So it should reduce. It should not never increase. Okay. It should reduce. Just like you will see that if I go with this rule, my initial Gini is 0.66%. And with that rule, straight, I am getting a rule for Setosa. And that is a stable state. So it's a stable state. And here the Gini is 0. You can see it. But on the right side, you are getting 81 samples. That's like 41 plus 40. So it is like 81 samples. Okay. And which is the majority? Versicolor. And here also, what is the majority? Versicolor. Okay. And you are further dividing on the criteria of petal width. Okay, look at it. First criteria was petal length. Now the second criteria is petal width. Now what is this petal length and petal width? They are the variables, independent variables. How it was chosen? Why it was not petal length again? Because it has done the calculation in the background that you will get the impurity reduction at petal width only, not at petal length. Maybe impurity like Gini index was 0.55, but at petal width it was 0.5. That's why it has taken the petal width. Okay. Now at this, how many classes are there? 2 classes are there. 1 class is sorted. Okay. Setosa is set. No need to go over there. So now the fight will be only in between that versicolor and virginica. Now, if you do the criteria, you will find that the impurity right now here is 0.5, which is like almost, there will be some decimal points, but it's almost 50-50. Okay. Here, petal length is there. Okay. So you can see that the petal length, if you split by the petal width, you will find that the impurity is reaching to a good state. Now the impurity is at 13% only. And while for that greater than, it is like impure Gini is 0.51. 0.051. So here impurity reduction is happening more in comparison to this one, because it's 40:3 and here is 1:37. Okay. And you will see that another split and we are done almost. Okay. You can see that very, very kind of a stable state for virginica also. And here also for virginica. Okay. So that's the whole play. Now you will see that at any point of time, impurity was never greater than 67%. Because this algorithm is made in such a way that it will always reduce the impurity. At any point, it finds that impurity is getting increased. Okay. Further down the line, it will not split, or it will check for another variable to split. If it is there, if it is going beyond, going below that, it will check another. It will check another. So it will check to all independent variable availables. Okay. So understood. I want a little acknowledgement from you guys. How is the decision tree classifier going on? So Shweta, you also did the calculation for 0.66. You did the whole calculation. Oh, great. So this is the kind of moment I search in my classes, that students are engaged in such a way that they are doing something in background. Okay. A student sitting there, not interacting and not doing any calculation is nightmare for me. Okay. So thank you for doing that on the background. Yeah. Yes, but why it is changing from pedal length to pedal width? So CV sir, the point is that you should reach to a stable state, whether you should follow the longer route or any kind of thing. The point is that you should reduce your time to the travel. If you take this lane or that lane, okay, the point is that timing should be reduced. Yeah. No. It's not random selection. You have an option in classifier to say that. So why it is changing from like pedal length to pedal width? Because in the background, it has again checked for pedal length, and for all the variables it has checked at which point or which particular variable I am getting the impurity reduction. Okay. Try to do it by yourself also. You will find that at first split, it's not like the shortest path. It's like the impurity reduction. Just like when you're driving on Google Maps, okay, you might have seen that when you begin for a long journey, it provides you an option. If you follow this route, which is like the highlighted one, and there are some routes which are shown to you, this will take with the tolls, this will take without the tolls, and you will find that with the tolls, the route is usually short and in length also it is short. But during traffic conditions, some routes are shown reverse. Like it will be kilometer wise or miles wise, it will be long, but in terms of time, it will be less. So you go with the longer kilometer, but you ultimately reduce your time. Okay. So let's take time is your ultimate criteria to go to a destination. So whatever you will do, you will check that for every route in your Google Maps. So let me just try to do it also. It will be too much. Okay. Let me just provide here. For example, in map, it's here your destination, and here are some routes showing up. Let's say it's saying that 1 hour 23 kilometers. Not a constant pattern, sir. It's the constant criteria, not the pattern. The criteria is Gini. It should reduce. Okay. And look at this example first. Let me just choose a different color. So what happens in real-time Google Maps is that they show that this is also an route, but it shows that it is like 1.3 hours and it is like 26 kilometer. And there is also a route which is shown to you in a grayed out area, like in a gray format. It says that it is like 50-minute, and it is also, let's say, 21 kilometer. No, let's make it 2 hour, and it is 21 kilometer. Okay. Now there are how many routes are there now with you? Let's the route 1, which is 1 hour 23 kilometer. Route 2, 1.3 hour 26 kilometer. Route 3, 2 hour 21 kilometer. Okay. If your time is your criteria, then your choice will be, oh sorry, not this one, this one. You are actually traveling 2 kilometers more in terms of your fueling and running, but you are saving 1 hour. Okay. You are saving 1 hour. So keeping here also, Gini reduction is there. Like this hour should be reduced. If you take this route or that route, it really doesn't matter. Your reduction should be there in the times. Yep. Yep. So correct, Shweta. Okay. So here the criteria is Gini reduction. So in the background, it is only showing you in the diagram that it has chosen this route. What happened to this? In the diagram, it is showing you that this is that petal width, but in the background, it has checked petal length, sepal width also. Okay, and it will split, and it will show up the split only where it find that the reduction was there. Maybe Gini was for the petal length was more, so that's why it is not split it up. Okay. So that is the all story for it. Okay. You will see that in this explanation, I've only drawn it to the level of 1, 2, 3, 4. But in the actual diagram, it is up to that level of 5. And what you will see, which is not considered good, is that in the end, so Veeramani, you're saying that, but we take decision from starting point itself and not in between the travel. No, it mean in between the travel. In between the travel also. Yeah. For example, you are traveling from your home to a destination. Okay. Let's say you reached here at this green point, but sometimes some congestion is happening over here in the red. You often see this. And here, some sort of congestion is also there. Some sort of congestion is here. But here it's like a long congestion. And here it's like a short congestion. But route suggests you that, hey Viramani, if you take a little diversion from here and also a little diversion from here and take this route, I don't know it's visible or not, but it says that Viramani, please take this diversion and this diversion. Okay, you will find that this reduction is more because on your route there is a congestion ahead. Okay, so here also in between travel you can choose up depending upon your time reduction. So ultimately your goal is that time. In this Google Maps example, 1 hour. Okay, if there is something happening on the routes, still it will suggest you the path where you can save time. Okay, it can be also like going into some small lanes, but ultimately the goal is that time should be reduced. Okay, so here also, depending upon the Gini index or the reduction you are going with your travel in the decision tree, it can choose which of the variables to choose. Okay, and also the points, like at particular which. Okay, now here what is happening, that it is splitting at one node. Okay, you can see that the versicolor is at 1, Virginica is at 1, and here also it is splitting to the last leaf node. Okay, only one particular data point is there. Okay, it's called overfitting. If you see the score of training, then you will find that this is happening. Let me just put it here. Lottery. Yeah. And this is what I have plotted, is that I have plotted the X column. It means that independent variables. Okay, not the test or uh, training. Okay, this is all. Now, what it will do is that CLF score X train Y train. You will see that the training score is 100%. And that's why, because it is splitting to that, it is just memorizing the data, just like in our analogy of cricket. It is just learning the training. Okay. And you will see that at scoring, X test, Y test. During test, what happened? Give me a moment, guys. Okay, I have to run it again. Just a minute. Split. Yeah. Let me show it here. CLF, that is our classifier, dot score, X train, Y train. Training score is 100%, testing score is 96%. Okay. So you can see that memorizing is not good. Okay. That memorization has just given the score down. Okay. So what it means that in terms of this diagram. Yeah. So it means that your model is overfitting, because that's why overfitting means that when you're training model, the model that you made on the training data is giving you 100% score, and on the testing it is less than what it had scored on the training. Okay, so some overfitting is there. How to spot a overfitting in a decision tree? You will see that it is splitting out to the leaf nodes also up to the last point, and one data is being classified as into categories. Okay, that should not be there. What is a good classifier doing? Like identifying those stable states where majority of the class is identified. Like 39 setosas uh, are identified just with one decision. If your petal length is less than 2.6, then you will get 39 setosas, all setosas in the training. So that's why that testing score is also good, because this is a kind of a rule which distinguish more better. Okay. This is like more general rule. And what about this rule? Like, let's try to reach to this node. If petal length is less than 2.6 and petal length is less than greater than 4.75 and petal width is less than 1.75 and petal length less than 5.35 and petal width is less than 1.55, then you will reach to this particular leaf. Look at the rules that it has on top of it. Okay, it's not like a more generalized rule. Okay, if I give you this rule based approach to an analogy, okay, to an analogy, let's say your friend is in a different country, or let's say you are inviting your friend to your country, and you just wanted to give directions to your household, to your home, or to most of the grocery stores in your area. How you will give the direction to your friend? Okay, first of all, get up from the airport. Okay, pick a taxi and go to this area, and this area you will find Go to that zip code, and in the zip code, go to that block, and in block you will find on the left side there are many shops, and you will find some grocery stores over there. Okay, if you give too much direction to one of your friend, and then also to your another friend also, you will have to pass that one. So something like that. So too much information is not great always. Okay, give a direction which will help to locate to an area where they can also find it. Okay, so here also decision tree. In decision tree, you don't have to go to the pinpoint. You learn in the pinpoint way. You will have to have a bigger idea or generalized idea, so that a new data is there, you will be able to predict. And that's what happening in this case, 96.6% of accuracy on testing. Okay, so why that gap of 2.3 or 3.3%? Because that learned pattern was not working here. Okay, that was too much learning the small details which are not even important. Okay guys, we have only 5 minutes. Tell me guys, what you want, like to do this one more time. I would say that try to do it by yourself and come up with the questions. In the next class tomorrow, I will be happy to have questions from decision tree. I will devote like somewhere around 15 to 20 minutes only for the doubts, because this is important. That splitting criteria, you should be aware about it. Okay, so please suggest me. Okay, thank you Shaka for acknowledgement. Okay, so I'm almost 4 minutes. Anything that I can help? And I will upload. This is already uploaded, guys, on LMS. So everything is there with you, and the PPT is also there. Okay, guys. So that was all for today. I will stop my share. Okay, guys, let's meet tomorrow then. Goodbye. Thank you, Steve sir, and also please try to rate this session. If you find it good, please rate it. It will help me, and it will help the admin to repeat this session for another people, so that they can also refer this recording or have a direct record. Yep. Okay, guys. Thank you. Thank you all.